Hello everyone. In this lecture, we are going to discuss the order of the system. Means how to determine the order of the system. See, in control system, especially in time domain analysis, we are going to heard this term like order of the system, like first order of the system, like second order of the system, and so on. Okay, so what is meant by the order of the system? Order of the system is nothing but basically it's related to the power of S. So we are having our transfer function in S domain. So in that S domain, the power of S in the denominator will show the order of the system. Okay. So coming to this transfer function, let the transfer function Ts equal to K into Ps by Qs. Okay. So after solving the transfer function by taking output transform by input transform and by solving this, we are going to get some form like K into Ps by Qs. Okay, where Ps is nothing but numerator polynomial and Qs is our denominator polynomial and K is the constant. Okay, see here I am not saying Ps is output transform and Qs is input transform. Why I am saying Ps is numerator polynomial and Qs is denominator polynomial? That means we know transfer function Ts equal to Cs by Rs. So we basically see transfer function in this form Cs by Rs where Cs is output transform and Rs is input transform. Okay. So by considering this means Ts equal to Cs by Rs, this form, we are going to solve this transfer function after taking by Cs and Rs form. Okay, and we are going to modify this or simplify this. Okay, after modification we are getting simplest form of this transfer function and the resultant of transfer function in the form of K into Ps by Qs. Okay, so if our transfer function is in this form, after simplification we are getting some equation and then we need to compare this equation. Okay, where Ps is our numerator polynomial and Qs is our denominator polynomial. Okay, so see here, whatever the order we are going to mention for a system that is dependent upon the denominator polynomial. That means S power in the denominator polynomial will show how much order of the system is having. So here the denominator polynomial will be in the form of like this, where Qs is our denominator polynomial and this denominator polynomial is equivalent to a0 into s to the power n plus a1 into s to the power n minus 1 plus a2 into s to the power n minus 2 dot like this. Okay, and this is equal to 0. So here we can take this as a polynomial, this equation as a polynomial equation. Okay, and here we consider n, if n equal to 0, then it is called zero order system. Okay, for considering n equal to 0, then the equation will be, that means the denominator polynomial Qs equal to, if n equal to 0, then this is Qs equal to a0 into s to the power 0, that means this is 1 a0 plus a1 into s to the power minus 1 plus a2 into s to the power minus 2, like this. Okay. So if the denominator equation like this, that means considering n equal to 0, the denominator equation is a0 s to the power 0 plus a1 s to the power minus 1, like this. Here see, the highest power of s is equivalent to 0, and then we can see this is a zero order system. Okay, so that means if the highest power of s equivalent to 0, that remaining s power may be in terms of minus, then we can say it is zero order system. Okay, now come to the first order system. So what is meant by first order system? Okay, so in case of first order system, we take n equal to 1. So if we take n equal to 1, then the equation will be a0 into s to the power 1 plus a1 into s to the power 0 plus a2 into s to the power minus 1, like this. Okay, so see when first order system is given, the highest power of s in the denominator is equal to 1. Okay, like this, when we observe that, when you observe in the transfer function, the maximum power of s in the denominator is 2, that is related to second order system. Okay, I think this is clear, all of you, what is order of the system. Okay, so today I stop here. Thank you.